Okay, so today we're going to be talking about mid segments, and segment addition, introducing it, and talking about congruent segments. What does congruent mean? So, congruent means if two geometric figures have exactly the same shape and same size, they're congruent. So, a segment, remember, a segment is a part of a line, right? Part of a line that we can measure. So, we can't measure an actual line, but we can measure a line segment. Those have endpoints. Okay, if we say that segments are congruent, that means that the measurements are equal to each other. So this is the biggest important piece to know. So if one segment's congruent to another, that means they have the same exact measure. So here's an example of congruent segments. Okay, and right here you'll see that this right here is the symbol for congruency. It looks a lot like an equal symbol, right? Um, but we read it when we're talking about shapes. Right? That's when we really use the congruency mark. We're talking about the shapes. When we talk about the measures and numbers, that's when we use the equal symbol. So in this case, we're saying that the shape AB, right, line segment AB, is congruent to line segment CD, right? That's when we use congruent. Now, if we're talking about the measures, right, then obviously we'd say AB is 1.7 and CD is 1.7. We use these little marks. You see this mark right here, this pink mark on both of these line segments. Those are what we call congruency marks. And those identify whether the two pieces are congruent. Sometimes you might have multiple markers. That's to differentiate between the several different line segments if it should come out. Okay? So, line segments, what are they and what can we do? Okay, so measuring segments, that's the distance between 2 points A and B, written as the length of A to B. Okay, and then uh, we would use that when we're doing our line measurement. Sometimes we would count on our line measurements and see what the cases may be for those. Okay, so you can count, pause for a moment, and you can count on that situation um, if you want to. Okay, that's the length of AB. Okay, and you should be able to see that AB is 4. Now, that's the distance between the 2 points. Distance is always going to be a positive value, even if you're going left or right, because we're talking about length, a measurement. It's always going to be positive. It shouldn't be negative. Okay, so um, make sure we talk about, sometimes you might hear the word absolute value. Okay, congruent segments. Okay, so for instance, if the lengths are equal to each other, kind of like what we said earlier, see how AB, 1, 2, 3, 4, that's 4 lengths, and 1, 2, 3, 4, that's 4 lengths. They both have a measure of 4 units. So we can say that AB is equal to CD, right? We're using the word equal because we're talking about their measurements. Then the segments are congruent. If their segments are congruent, then we write it as AB is congruent to CD. And we can do that. There's multiple ways to write that, but that's probably your best bet. Now, we do have this thing called segment addition postulate. We're going to focus a little bit more on that tomorrow. But segment addition postulate states that if A, B, and C are collinear, remember, collinear means together on the same line. So that means they're all on the same line together, and B is between A and C, then AB plus BC equals AC. Okay, so we're talking about this measurement plus this measurement equals the whole entire measurement. That's what we're talking about, segment addition postulate. So for instance, if this was 3 and the whole length was 10, we could find this out by using our segment addition postulate. And this is your geometry behind it, by the way, right? Now that we have some geometry, we can put some algebra behind it, right? And we can actually solve for our missing piece. AB would be 3. BC is our unknown, so we're going to leave it as BC, and AC is 10, right? That's how we could set it up. Subtract 3 to both sides, and BC equals 7, right? So that's just a quick example. We'll touch more about that tomorrow, Okay. A midpoint of a line segment. So this is important. A midpoint of a line segment, this is definition, is the point on a segment that bisects. Remember, that cuts it into two equal pieces, the segment into two congruent segments. The midpoint of a line segment is a point on a segment that is at the same distance or halfway between the two ending points. This is going to be very important. There's two different types with midpoints. Today we're going to discuss it on a line segment. Next week we'll discuss it using an actual formula. Okay, so let's be very, very careful and mindful of that stuff. Okay, so midpoint. The midpoint of a segment is a point that divides a segment into two congruent segments. Okay, a line, array, or segment that intersects a segment at its midpoints is said to bisect, right? There's that word again, bisect. Oops, sorry. The segment, and it's called the segment bisector. So if a ray goes into the midpoint, or a line, or another line segment goes into the midpoint, it's called a segment bisector. Okay. In the diagram to the left, you'll notice that B is the midpoint of AC. So it's going to cut AC in half, right? Line L, right? That's this line right here. Line L is a segment, or is a segment bisector of AC. That means it's cutting AC into two equal pieces. Notice a little congruency marks again there. Okay. So remember, biggest part is it means it cuts it in two equal pieces. So here's a couple of examples of midpoints. Okay, so if Q is the midpoint, again, we're talking about midpoint of PR, find the value of X. So because it's the midpoint, that's huge. That's the biggest definition, the midpoint part. Okay, we can say the geometry behind it, if you will, because it's the midpoint, says that PQ is congruent to, right, QR. And this is because it says midpoint. With that being said, right, our algebra, right, oops, not geometry, our algebra says that PQ is equal to QR. So we can substitute and use our values. PQ is 7x minus 16, right? And QR is 4x plus 2. So 7x minus 16 equals 4x plus 2. And yeah, I'm doing it pretty slow because I want to make sure that we understand what's going on here. You might have already seen that, and that's okay. So now we can set up our algebra and we can start to solve. Right? From here on, it's pretty easy stuff. Using our geometry features, we can come up with our algebra. So I'll do this real quick to help you guys out. Start off, right? We want to get our x's to both sides, so we subtract the 4x to both sides. Okay. This will cancel because it's 0. 0 plus 2 is 2. 7x minus 4x gives me 3x. Remember, we don't want to combine this 16 because it doesn't have an x, so we just bring it down. Okay, now that we got our x's on both sides, now we want to isolate. So we get rid of everything else. The first thing we need to get rid of is that negative 16, and we want to do the opposite. So we add 16 to both sides. Okay, so we get 3x equals 18, and then we divide both sides by 3. Okay, and we get x equals 6. All right, so we have this value for x, and we're going to place, if we needed to find the whole segment, we could plug it back in. Okay, so that's just a quick example. All right, we got two more we're going to hit up. Okay, so again, remember the geometry. H is the midpoint of GI. So by definition, that means that GH is congruent to, right, HI. Okay, they're congruent, that means they're equal. So that means that 5x plus 2 equals 9x minus 10. So these are a little bit different because it says find GH. So we're going to solve for x, right? That's the hidden part. And then we're going to plug it in to find GH, right? So in doing so, we do some algebra. Minus 5x minus 5x. 2 equals 4x minus 10. Add 10 to both sides. Add 10 to both sides. 4x equals 12. Divide both sides by 4. X equals 3. Okay. Now, that's not quite the answer because it's asking for GH. So we plug it in for GH, right? GH equals 5x plus 2. So 5 times x plus 2. We're going to plug in our new value for x. We just found it, right? So we plug it in, right? Plug it in. 3. 5 times 3 is 15. 15 plus 2 is 17. So there's my GH. Okay. So that's kind of a hidden question. It says find GH. So we actually have to solve for x in order to find GH. So we got two more examples. Same exact stuff, right? Pretty easy. R midpoint QS. Therefore, QR is congruent to RS, right? By definition, that means they're equal to each other because they're congruent. 2x plus 16 is equal to 5x minus 17, right? Do some algebra, subtract your 2x, subtract your 2x. We get 3x minus 17 is equal to 16. Add 17 to both sides. We get 3x is equal to 33. Divide both sides by 3, and x is equal to 11. Okay, we're almost done now. It says find QS. So QS is the whole thing. So here's the trick on this one. Because it says midpoint, and this is pretty awesome, is you can plug it into either one, right? So watch this. I'm going to plug this into QR. And I'm going to do this on purpose because it's addition. And addition to me is always easier than subtraction, right? So 2 times 11 is 22. 22 plus 16 is 38. Well, if this piece is 38 and they're equal to each other, that means that this is also 38. And 38 plus 38 gives me 76. Okay? Check my math on that, but I'm pretty sure I'm right. So the whole thing, QS, is equal to 76 because they have to be equal to each other. Now you can double check, make sure you plug the 11 in here and see if it works. Should. Okay. So there's those types of questions. Now here we go right here. This is going to be interesting, right? If G is the midpoint of FH, right? And FH is equal to 6y minus 2, find y. Oof, this is a big one. So watch this. Okay, so we know they're equal to each other, so we can solve for x. That's the hidden part. Once we solve for x, we want to find the whole value, right, number-wise, and then set that equal to the 6y minus 2, right? So we're going to go ahead and do the algebra quick because we already did a couple of examples. We know that they're equal to each other. These two pieces are equal because of the word midpoint. Okay, we solve, subtracting our 4x's. Okay, 3 equals 3x minus 12. Add 12 to both sides. We get 3x equals 15, right? X equals 5 by dividing by 3. Okay, so that's not the answer. We can plug that in. Again, I like to plug it in for the addition part, me personally, right? So FG is equal to 4 times x plus 3. We now know that x happens to be 5, so we plug that in, right? 4 times 5 is 20. 20 plus 3 is 23, right? So if FG is 23, that means that this GH is also 23 because they're equal, right? Congruent means equal. So that means the whole thing is equal to 46. So that means that 6y minus 2 is equal to 46. Now we can solve for y by setting up our equation. So I'm going to go ahead and bring this down here, right? 6y minus 2 equals 46. Do some algebra, add the 2 because we want to isolate for the y, right? 6y equals 48. Divide both sides by 6, and y equals 8. Now we have both x and y, and we've solved. Okay, so remember, again, midpoint is saying that we are congruent. It's a segment bisector. Okay,